Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our Artificial Intelligence and Machine Learning lecture series, we are going to discuss about the topic dimensionality reduction. This topic is comes under the unit number 4, that is neurons and neural networks. So already we know what is actually a dimensionality that we have discussed in the very first unit. That's the fundamentals of artificial intelligence and machine learning. So now, and also we have discussed what are the drawbacks we are facing when you are increasing the dimensionality. Dimensionality means it's increasing the features. So how we can reduce the dimensionality, that we are going to discuss in this topic. So come, let's directly get into the topic. So, dimensionality reduction. It is a process of reducing the number of features or dimensions in a data set while retaining as much information as possible. This can be done for a variety of reasons, such as reduce the complexity of a model, to improve the performance of learning algorithm, or to make it easier to visualize the data. There are several techniques for dimensionality reduction, including principal component analysis, that is PCA, singular value decomposition, that is SVD, and linear discriminant analysis, LDA. Each technique uses a different method to the data onto a lower dimensional space while preserving the important information. So that reduction, it is possible for transforming high dimensional data into lower dimensional space that still preserves the essence of the original data. In a machine learning, high dimensional data refers to data with large number of features or variable. The curse of dimensionality is a common problem in a machine learning, where the performance of the model deteriorates as a number of features are increased. So this is because the complexity of the model increases with the number of features, and it becomes more difficult to find a good solution. In addition, high dimensional data can also lead to overfitting, where the model fits the training data too closely and it does not generalize well to new data. So dimensional reduction can help to mitigate these problems by reducing the complexity of the model and improving its generalization performance. So there are two main approaches to dimensional reduction. There is a feature selection and feature extraction. First thing, feature selection. So feature selection involves selecting a subset of original features that are most relevant to the problem at hand. The goal is to reduce the dimensionality of the dataset while retaining the most important features. There are several methods for feature selection, including filter methods, wrapper methods, and embedded methods. So let's see the classroom activity. It is a rebus puzzle. So as we know, what is the rebus puzzle? So find the appropriate answer for the given images within this 5 minutes. Okay. So let us resume the session. So what we have discussed is that is a feature selection. Now it is a feature extraction. So feature extraction involves creating new features by combining or transforming the original features. The goal is to create a set of features that captures the essence of the original data in the lower dimensional space. There are several methods for feature extraction, including principal compound analysis, that is PCA, linear discriminant analysis, LDA, and T-distributed Scottish neighbor embedding, that is TSNE. So an intuitive example for dimensional reduction can be discussed through a simple email classification problem, where we need to classify whether the email is spam or not. So this can involve a large number of features, such as whether or not the email has a generic title, the content of the email, whether the email uses a template, etc. Hence, we can reduce the number of features in such problems. So when your number of features, if it is reduced, the complexity also will be reduced. So that's the reason why the dimensional reduction is very, very important. Okay, let's have the assessment. So what is dimensionality reduction? The first question. And what is feature extraction? The next one, what is feature selection? And actually, what is dimensionality? And why this dimensionality is important? So these are all the 5 questions. So you take as the assessment. quickly, and the next session we will see the fifth unit topics. Thank you.